Hey guys, Mr. Y here. Just wanted to get going on our notes. Hope the Chapter 5 test went well for all of you. I'm looking to grade them this week and get them back as soon as possible. But we're going to jump into Chapter 6, which is really our last new section of information. Chapter 6 is all about factoring. So in this past chapter, we started learning about polynomials and how to add them, subtract them, and how to multiply them, how to take two parentheses against each other and make them into these polynomial expressions. And so basically what we learned how to do there was how to build a polynomial. What we're actually going to learn in factoring is how to take a built polynomial and take it back down to those more simple terms. So before we started with two parentheses and we multiplied across using FOIL and the different methods that we showed to get it to a simpler looking polynomial. Well, now we're going to start with those simpler polynomials and we're going to work it back into the two parentheses. But before we do that, we've got to start with some more basic principles to understand within that. So to begin this chapter, we're going to talk about three specific vocabulary words that you're going to hear about all throughout this chapter. And our first one is factor. And factor is just a number that can be multiplied to create a specific product. So when we say a number that can be multiplied, if we had the number, let's say 6. 1 is a factor of 6 because it multiplies against 6 to get to 6. 2 would be another factor of 6 because 2 goes directly into 6. 3 would be another factor of 6. And of course, 6. So factors are not only going to be multiplied to get to that number, but they also divide evenly into it. So when we talk about factors, we're either talking about that it was multiplied to create a specific product, or if we do the inverse of multiplication, which we've learned is division, then it easily divides into that specific product that we're working with. So when we talk about factors, we're looking at smaller numbers, or it could be the exact same number, but a number that can be multiplied to get to the number we're working with. Which brings me to our second word, which is factor pairs. And so these are two specific numbers that multiply together to make a specific product. So let's use that number 6 again. And so when we talk about factor pairs, these are two factors that go evenly into 6, obviously, but they multiply against each other to make the number 6. So our first factor pair is always going to be 1 and the number itself. So 1 and 6. So that would be a factor pair. 1 times 6 equals 6. Our other factor pair for this one would be 2 and 3, because 2 times 3 equals 6. So those are known as factor pairs. They're two specific factors that go together, that multiply against each other to make that specific product, which in this case was 6. So this right here would be considered a factor pair. Our last term we're going to talk specifically about in here is greatest common factor. And greatest common factor is the largest factor that all terms of an expression have in common. So it's going to be the greatest factor. So if we had 6 and 12 were the two numbers and we listed out the factors of them, 1 and 6, 2 and 3, and then 1 and 12, 2 and 6, 3 and 4. We may notice that they have multiple terms in common. They both have 1s in common, they both have 2s in common, they both have 3s in common, but the largest factor that they have in common would be 6, and that's known as the greatest common factor, or for short, you'll hear it referred to as GCF. And GCF just, of course, means greatest common factor. So those three terms are going to be terms that you hear over and over throughout this chapter when it comes to factoring. Is we're going to list our factor pairs, we're going to work with these factors, we're going to talk about the greatest common factor. So let's talk specifically, though, about that greatest common factor. And we're going to talk about today how to find the greatest common factor. And so we've got some steps listed there on your paper for you on how to find the greatest common factor. Step 1 is we're going to list out all those factor pairs. So kind of like what we were doing on the examples here, is we're going to list out all of those factor pairs. When we deal with terms that have variables like 4x squared and things like that, we'll talk about that and how we write out those variables. This will go in that step as well. Step 2, we're going to find the largest common number in each list. So we're going to look and see what's that biggest number. So like here, we had multiple numbers in common, but the biggest one was 6. Now when we're doing this, I always recommend start with your smallest term and check that biggest number. So that's going to be the term itself, and see if that is in the other term. So if we had started right here at 6, which is the largest factor of 6, and gone over here, oh, yes, we have that, and we would have only had to check one factor, but because on the example I started with 1, we had to go through 4 factors before we found it. So we're going to talk about start with your smallest term, so the smallest number. We're going to use that number itself and check. Well, if 6 hadn't been there, then we would go down to 3 and we would check until we found that common number. Now, if it is in the list like we just talked about, then there's your GCF. That makes it simple. If it's not, then we just keep going down that factor pair list until we find the GCF. So we'd go 6, 3, 2, 1, all the way down. So those are just the process that we're going to use to figure out our greatest common factor. Now at the bottom, I've given you a couple little just tricks and trades, some shortcuts to seeing if you have these factors. First one is 1 is always a factor. 2 is a factor if it ends in 0, 2, 4, 6, or 8, so even numbers. 3 is a factor if the digits add to a multiple of 3. So like, let's take 12 for instance. If we add 1 and 2 of the 12 together, we get 3. Well, right there we know that 3 is a factor. 4 is a factor if the last 2 digits are divisible by 4, so we don't even have to check however many digits there are, just the last 2, see if they're divisible by 4. 5 is a factor if it ends in 0 and 5. 6 is a factor if 2 and 3 are both factors of it. 9 is a factor if the digits add to a multiple of 9. So again, use an example of 36. So we add the 3 and the 6 together. That becomes 9 itself. So that is a multiple of 9. So that works. And 10 is a factor only if it ends in 0. If it doesn't end in 0, you know 10 is not a factor. So those are just some cheat codes. You don't have to use those, but maybe they might be helpful for you if you don't have all your multiplication facts memorized, because this is a exercise, this first early part on not using our calculator, creating these factor lists without using the calculator. All right, so if you'll flip over to the other side, we've got here 8 examples that we're going to work with. And we're going to start with the first one, and we're just going to work with only numbers. So example A says, hey, you've got numbers of 24 and 48. All right, what is the greatest common factor? Well, we're simply just going to start with 24, create the factor pair list, then we'll move over to 48, make sure we've got all the factor pair list of that one, and then we'll go through that process. So let's start with 24, and I'm going to teach you to figure out how you know if you have all your factors. So start with 1 and 24, and I just like to line them up right next to each other. So 1 and 24. Then I'm going to move on to 2. Does 2 go into 24? Yes, it does. So 2 times 12 equals 24. Then I'll move on to 3. Does 3 go into 24? Yes, it does. 3 times 8 equals 24. Does 4 go in? Yes, it does. 4 times 6 equals 24. Does 5 go in? No, it doesn't, because it doesn't end in 0 or 5. Does 6 go in? I've already got 6 on my list. That means my list is complete. When I have hit a number that is already on my list, I know that I have every factor pair that's in, as long as I go in order just like I did right there. So let's go to 48, and let's start with that one. So I've got 1 and 48. Does 2 go in? Yes, it does. 2 and 24. Does 3 go in? Yes, it does. 3 and 16. Does 4 go in? Yes, it does. 4 times 12. Does 5 go in? Nope, doesn't end in 0 or 5. Does 6 go in? Yes, it does. 6 and 8. Does 7 go in? No, it doesn't. Does 8 go in? Oh, 8 is already on my list. Now you may have noticed as we do these factor pairs, these two numbers start really far apart, and as we go down our list, they slowly start getting closer together. Oh, 6 and 8, that's really close. Typically that's going to be an end. When you've only got one number separating, that's going to be the end, but we always check that one number just to make sure. So now I've got two complete pairs of factor lists here, so factor pair lists. for these. So now what I recommend is go to your smallest term. So 24 and 48, 24 would be my smallest term. And I'm going to start with the number 24 itself. And I'm going to say, all right, this has a 24 factor. Does this one? Oh, yes, it does. So right here and right here. So by starting with that smaller one, I already found the greatest common factor, which is 24. So my GCF colon is 24. Greatest common factor. All right, so let's jump on to example B now, and we're going to do the same thing. We're going to create those factor pair lists for each number, starting with 15, then going to 24, then going to 36. This is something that I want to see the work on for problems like this. All right, you may be able to look at these and know, and that's fine come test time. But for right now, we want to get that repetition of figuring out factor pairs so they're ingrained into our memories. So let's start with 15. We've got 1 in 15. Does 2 go in? No, it doesn't. Does 3 go in? Yes, it does. 3 times 5 equals 15. Does 4 go in? No, it doesn't. And 5 is already on my list. So that is a complete factor pair list. Now I'm going to do 24. So 1 and 24. Does 2 go in? Yes, it does. Now you may remember that we did 24 on the last example. So if you've done that, you can kind of cheat. Hey, oh, there's my factor pair list and do that. So does 3 go in? Yes, it does. 3 and 8. Does 4 go in? Yes, it does. 4 and 6. And does 5 go in? No, it doesn't. 6 is already on my list. Now I need to go on to 36. So 1 and 36. Does 2 go in? Yes, it does. 2 and 18. Does 3 go in? Yes, it does. 3 and 12. Does 4 go in? Yes, it does. 4 and 9. Does 5 go in? No, it doesn't. Does 6 go in? Yes, it does. 6 times 6. This is an immediate indicator that you have finished your list. When you end up with a double number, it's the same number. It's already on your list, so you know that that is the end of your list. All right, so we've got our complete lists of factor pairs. So let's go now back to our smallest term, which is 15. Start with 15 and see if it's on all 3 lists. So 15, it's on this list, but it's not on this list. Even if it's on this list, it can't be greatest common factor because it has to be in all 3 lists. So not an option, so I'm going to cross that one out. 5, need to check for 5. Is 5 on all the lists? It's not on this list, so already know, not an option. So now I'm going to go on to 3. Is 3 on this list? It's on this one, it's on this one, and it's on this one. So right there is my greatest common factor. So greatest common factor of 15, 24, and 36 is 3. All right, so this is the part of the video where I'd encourage you to pause it, create those lists for 24, 60, and 96 on example C, figure out the greatest common factor, then unpause it and check your work against mine. All right, well, I'm going to continue on though. So we're going to start by creating that factor pair list for 24, 60, and 96. So starting with 24, again, I've already got that one. I did it in the first 2, so I know that 1 and 24 work. 2 and 12 work, 3 and 8 work, and 4 and 6 work, and my list is complete. Now I need to go on to 60. So 1 and 60, 2 and 30 work, 3 and 20 work, 4 and 15 work, 5 and 12 work, and again, these pairs are slowly getting closer together, 6 and 10 work. Does 7 go in? No, it doesn't. Does 8 go in? No, it doesn't. Does 9 go in? No, it doesn't. 10 is already on my list. So bam, I'm finished with that list. So now I got to do 96. Well, this is a little bit bigger number. And I'm going pretty quickly through these factor pair lists because I've been doing this for a long time, so they're ingrained in my memory, much like they will be for you if you continue to make these lists. But it may take you a little longer as you do your assignment to create these lists. All right, let's go on to 96. So first one, 1 and 96. Does 2 go in? Yes, it does. 2 and 48. Does 3 go in? Yes, it does. 3 and 32. Does 4 go in? Yes, it does. 4 and 24. Does 5 go in? No, it doesn't. Does 6 go in? Yes, it does. 6 and 16. Does 7 go in? No, it doesn't. Does 8 go in? Yes, it does. 8 and 12. Does 9 go in? No, it doesn't. Does 10 go in? No, it doesn't. Does 11 go in? No, it doesn't. And 12 is already on our list. So our list is complete. Again, this may take you a little longer. You might have to write some stuff out to the side, doing division. All of that is completely fine. It's a part of the process of getting this ingrained into our memories. So again, once we're at this step, our lists are complete. Now we go back to our smallest term, right? And we start with the biggest number. So 24. Is 24 in all the lists? 24 is in this list. It is not in this list, but it is in this list. But because it's not in all three lists, it is not a greatest common factor. So now we need to check 12. 12 is in this list. It is in this list. And it is in this list. So it is in all three lists. It's my next biggest number. And so that is my greatest common factor. So GCF is 12. All right. Again, I'd encourage you on example D, pause it on your end. Find the factor pair lists of 30 and 45. Figure out what the greatest common factor is. Then check your work against mine. Now I'm going to move on to doing 30 and creating my factor pair list. So 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in, 5 does go in, 5 times 6 equals 30. 6 is already on my list, so my factor pairs are complete. So now I need to move on to 45. So first one, 1 and 45. Does 2 go in? No, it doesn't. Does 3 go in? Yes, it does. 3 and 15. Does 4 go in? No, it doesn't. Does 5 go in? Yes, it does. 5 times 9. Does 6 go in? No, it doesn't. Does 7 go in? No, it doesn't. Does 8 go in? No, it doesn't. 9 is already on our list, so that factor pair list is complete. So again, now we go back to our smallest term. We go back to the number itself, and we start there. Is 30 on both lists? No, it is not, so not an option for the greatest common factor. Next number, 15. Is 15 on both lists? It's on this list, and it's on this list. So right there, I only had to check two numbers and found that the greatest common factor was 15, or is 15. It will always be 15. So that's how we do it when it's just numbers. Now we're going to move on to these final four examples, and we're going to talk about examples with variables and how that changes things just slightly, but not a ton, right? It's really just building off of what we just learned. We start with the numbers. We're going to start with coefficients, and we're going to figure out all the factor pairs of it. So like on example A, we're going to start with this 12, find all those numbers. Then we'll talk about how we can list out these variables, and we'll do the same for the second, and we'll figure out what they have in common. So let's jump on to example A here. So example A says 12a squared c squared. So again, let's start with this coefficient of 12. What are the factor pairs of 12? Well, first one, 1 and 12. Then we've got 2 and 6, 3 and 4. 4 is on my list, so that is complete. Now let's talk about these variables. We have a squared and c squared. Now a squared we've learned means a times a. So what you really have is a and a. You have two of those a's. That's important, all right, to remember. However many number you see here, we need to list out that many of the variables. So I have a 2 here, so I have 2 a's. Well, I have a 2 here on the c, so I'm going to have 2 c's. All right. Now we're going to go on to our next term right here. 32ac to the third. So here we go, start with the number 32 and work and create its factor pair list. So first one is 1 and 32, 2 and 16. Does 3 go in? No, it doesn't. Does 4 go in? Yes, it does. 4 and 8. Does 5 go in? No, it doesn't. Does 6 go in? No, it doesn't. Does 7 go in? No, it doesn't. And 8 is already on our list. So we have the complete factor pair list of the number. Now we need to do the same thing with our variables that we did over here. So how many a's do I have here? Well, I don't see an exponent next to it, which really means it has an exponent of 1, like we've been talking about. So we really have just one a right there. Now C, it has an exponent of 3. So that means I have 1, 2, 3 C's being multiplied there. That's the factor pair list of C. So now I've got complete factor pair lists here. So first things first, going to start with the numbers, the smallest number that we have, which is 12, and we're going to start with 12 and see if it's on the list. So 12, it's here, but it's not here, so not an option. 6 is the next number. Is 6 here? It is. Is it here? No, it's not, so not an option. Right? Is 4 my next number? Is 4 here? Yes, it is. So that is a part of my greatest common factor. Now, when we have these variables attached, that usually means that there's going to be a variable in the greatest common factor. So we need to see, one, do they have the same variables? So both of these have a's. All right, we noticed that this one had a squared, this one had a to the first, so there was 2 a's here and 1 right here. So what's the greatest amount of a's that's in both lists? Well, this one only has 1a, this one has 2, right? I can't have 2 in this one because there's only one of them. So that means my greatest common factor of a's is just one of them. So just one of the a's is a part of the greatest common factor. So that's going to leave this extra a over here, and that's completely fine, all right? But only one a in this list. Same thing on the c's. What's the greatest amount of c's that I have in both of the lists? Now this one has 3, but this one only has 2 of them. All right, so that means that the max I could use would be 2, because I have 1, 2. I don't have a third one to circle, but I have 1, 2 right there, and it just leaves an extra c, and that's completely fine. So now when I look at this list and I'm going to figure out my greatest common factor, first thing I start with is the number, all right, which is 4. Then I do my next variable, which is a's. Well, how many of those a's do I have in the list? And I only really need to look at one of the lists. So 4a, only one of them, so a to the first, or just a. And then c's, I have 1, 2, so that is known as c squared. So my greatest common factor of these two terms that we just worked with is 4ac squared. Because the greatest number they have in common is 4, the most a's they have in common is 1, and the most c's they have in common is 2, which we write as c squared. All right, so hopefully that made sense. The numbers portion definitely should, since we've done 4 examples of those. The variables might be just a tidbit confusing at this moment, but let's see if we can even clarify it further in this second example, example B. So again, 10x squared y and 15xz. So we need to figure out, what do I have in common, and what's the greatest amount of it I have in common. So let's start with the number 10. Factor pairs are 1 and 10. 2 and 5, 3 doesn't go in, 4 doesn't go in, and 5 is on my list, so done there. Now I need to look at the variables, x squared, so how many x's do I have there? 1, 2, and then I have a y. Well, the exponent on this y is really 1, so I only have 1y, and that's going to go right there. Now next list, 15xz, start with the 15, so 1 and 15. 2 doesn't go in, 3 and 5, 4 doesn't go in, and 5 is already on my list. So now I need to go in, I've got xz, both of those have an exponent of 1 if we were to write them in. So I need 1x right here and 1z below there. Well, now let's take a look. Start with my smallest number, which is 10. Start with the 10. Is it in both lists? No, it's not, so not an option. Move on to 5. Is 5 in both lists? Yes, it is. So that's a part of my greatest common factor. So 5 is going to be the number. Then I've got x's here. Do I have x's here? Yes, I do. Do I have 2 x's in both lists? Nope, but I do have 1 in each list, so there's going to be 1x as a part of the greatest common factor. Now I look here and there's a y. Is there a y in this list? No, there's no y. So that means y can't be a part of the greatest common factor because it's not in both terms. Same thing here with the z. Z is not in both terms, so it can't be a part of the greatest common factor. So when I look for my greatest common factor, the things that I circled were 5x. And there's my greatest common factor. That's what they have in common is 5x. We could multiply 5x times something for both of these terms and come out with that is essentially what it's saying. So 5x, greatest common factor. All right, well, this is the part of the video. Encourage you to pause it. Try example C on your own. Create those factor pair lists. Circle the greatest common factors and write it out for yourself. Once you're done, unpause it. Check your answer against mine. I'm going to continue forward, though, and finish up this example C. So we're going to start with 50xy, create our factor pair list, and then move on to each term after that. So 50xy, so we'll start with 1 and 50. 2 goes in, 2 and 25. 3 does not go in. 4 does not go in. 5 goes in, 5 and 10. 6 does not go in, 7 does not go in, 8 does not go in, 9 does not go in, and 10 already on our list, so that is done. So now I come to the variables x and y. There's only exponents of 1 and 1 here, so I need 1x and 1y. Now I need to do the factor pair list of 80xy, so start with the 80. So 1 and 80. 2 and 40, 3 doesn't go in, 4 does, 4 and 20, 5 goes in, 5 and 16, 7 does 7 go in? No, it doesn't. 8 does 8 go in? Yes, 8 and 10. And then 9 does 9 go in? No, it doesn't. And 10 is already on our list. So we're done with the numbers. Again, we have x and y here. Exponents of 1 on both, so I need 1x and 1y. So then last one, 10xy to the third. So we'll start with 10. 1 and 10. 2 and 5. 3 doesn't go in. 4 doesn't go in. 5 is already on the list. So then I need to come to my x, y to the third. Well, x, its exponent doesn't show, which really means it has an exponent of 1. So I need 1x here. Now, y has an exponent of 3, so that means I should have 1, 2, 3 y's. All right, so now we've got complete factor pair list for every single term. So again, we're going to go back to our smallest number, which is 10, and we're going to start with 10 itself and see if it's on every list. So I see 10 here in this list. I see 10 here in the second list, and I see 10 here in my very first list. So that means 10 is the greatest common factor when it comes to the number. So 10, very simple right there because we started with the smallest term. Then I need to look at variables. So let's start with x. Is there an x in every list? I've only got 1 here, so I can only say that the maximum amount of x's I could use would be 1. So 1 here, 1 in the second list, and 1 in the first list here. So x is a part of it as well. Now I need to look at the y's. So are y's involved? Well, I've got 3 here, so the maximum I could potentially have in my greatest common factor is 3 based on this list. Do I have 3 here? No, but I have 1 y, so that means that the maximum amount of y's I could have for greatest common factor is 1. So if the third list has it, then that means y is a part of it. It does have a y, so that means I'm going to circle this y, I'm going to circle this y, and I'm going to circle 1 of those y's, because I only circled 1 in each one of those lists. Very good, so now I've got what I need to do my greatest common factor, so GCF dot, 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 all right, is, and I look at my list, 10xy. Greatest common factor, 10xy. All right, very good. Well, hopefully this is clarifying on the variables. It's getting much and much simpler to you. So again, I'd encourage you on example D, pause it, take a look at it, work it out, create the factor pair list, find the greatest common factor, then unpause and see if your answer matches up with mine. All right, so let's jump in. 21m to the 7th. Let's create that factor pair list for 21. So first factor pairs, 1 and 21. Does 2 go in? No, it doesn't. Does 3? Yes, it does. 3 times 7. Does 4 go in? No, it doesn't. Does 5 go in? No, it doesn't. Does 6 go in? No, it doesn't. And 7's already on the list. So that's complete factor pair list for 21. Now we've got m to the 7th. So that means we're going to have to list out 1, 2, 3, 4, 5, 6, 7 m's. There's 7 m's in that factor pair list. Now obviously that's really long, so I'm going to have to move my 18m to the 6 to the side. So let's start with that one. I've got all my terms listed for this one, or factors, excuse me. Now I need to list them for here. So let's start with the number 18. 1 and 18. Does 2 go in? Yes, it does. 2 and 9. Does 3 go in? Yes, it does. 3 and 6. Does 4 go in? No, it doesn't. Does 5 go in? No, it doesn't. And 6 is already on our list. So good, we're done with 18. So now, how many m's do I have? I've got 6 of those bad boys. So I got to go 1, 2, 3, 4, 5, and 6. So now I've got 6 m's listed. Now I've got to do my final term, which is 45m to the 8th. So start with the 45. So 1 and 45. Does 2 go in? No, it doesn't. Does 3 go in? Yes, it does. 3 times 15. Does 4 go in? No, it doesn't. Does 5 go in? Yes, it does. 5 times 9. Does 6 go in? No, it doesn't. Does 7 go in? No, it doesn't. Does 8 go in? No, it doesn't. 9 is my last factor because it's already listed on there. So we're good with that. Now I've got to list out all of my m's. And it says that I have 8 of them. So here we go. 1, 2, 3, 4, 5, 6, 7, and 8. All right. So now I need to look at my list, start with my smallest number, which out of 21, 18, and 45 is 18. So I'm going to start with 18 and see is it on every list. It's on this one, but it's not on that one. So I already know, not an option. Let's go to 9. Does 9 on every list? No, it's not. It's on 2 of the lists, but not the third one. So not an option. Is 6 on all the lists? It's not on this one, so we already know not an option. Is 3 on all the lists? 3's on this one, it's on that one, and it's on that one. So that means my greatest common factor number is 3. Now we got to go to those lists of m's. Well, this list had 8 of them, this had 6, and this had 7. So what's the greatest amount that's in every single list? Well, it's always going to be the smallest amount. So we've got 1, 2, 3, 4, 5, and 6. And I can have 6 here. And I can have 6 here. So 6 is my greatest amount of m's that is in all of the lists. So now I need to create my GCF. So GCF is, my number is 3. And then I've got an m. And how many of them do I have? Well, again, that was 6. So we have 3m to the 6th. Greatest common factor. All right, well, hopefully that cleared up the variable portion for you on what we're looking for. Again, you're looking for the most amount of a variable that's in all of the lists, not just one of the lists or 2 of the lists, got to be in all of them. The numbers, we're looking for those numbers that multiply together, those factor pairs that create that bigger number we start with, and then we're looking for what number do they all have in common. That's the biggest one of them. All right, so hopefully that answers all your questions. If you have any others, please feel free to reach out. We can set up a Zoom session, FaceTime, Google Meet, whatever is needed, phone call to work through this. But otherwise, you've got what you need to start on worksheet number 1 of chapter 6 and begin working with the greatest common factor.